and industrial systems, no matter global, regional, national, transnational, they all are complicated, distributed, and strongly interconnected networks of local facilities producing, transporting, and utilizing various products and resources. So that's why, due to, first of all, mentioned interconnectivity and closely associated with it multiple chain effects, these systems are often vulnerable to the natural disasters in such a way that the only one facility destruction may cause consequences far beyond place area where this facility is located. So one of the most valuable, actual, and at the same time difficult problem of the modern systems analysis is to develop widely available mathematical toolkit models as well as computer technologies which would provide the decision makers from government and corporate staffs precise prognostic information about such consequences. Let us illustrate the set by several slides. Here we see the industrial system which is manufacturing various objects by means of its technological base, utilizing proper resources. After natural disaster impact on this system, some segments of technological and resource bases are eliminated, and that causes the reduction of amounts of the object manufactured. By this, we may formulate a simple criterion to estimate robustness or vulnerability of the affected industrial system. If amounts of the objects manufactured before and after NDI are equal, so then we may say system is robust to this NDI. Otherwise, it is vulnerable. There is close to this problem, which we call reverse, what part of the work may be executed by the vulnerable industrial system after NDI. We shall formulate this problem verbally in such a way that how to assess consequences of natural disaster impact on industrial system, and is system vulnerable or is it robust to the impact. There is a lot of mathematical toolkits, general purpose and well known, which may be used, and they are already used, for similar problems solving. However, we introduce a new one, which is, in our opinion, more flexible and simple in application to large-scale industrial systems, as well as more efficient from the computational complexity point of view. This approach is strongly based on the recursive multiset theory, more precisely one of its sections, optimizing multiset grammars and metagrammars, which are the result of deep integration and convergence of classical mathematical programming and modern knowledge engineering. Here there are basic notions and definitions which are used lower. Multiset is simply a set of so-called multi-objects. Here we see multiset which contains from 3 multi-objects, 5 cars, 3 computers and 1 table. Multiset grammar is a tool that provides generation of new multisets from the already generated, beginning from the initial multiset called kernel, by means of scheme or set of rules, providing replacement of sub-multisets by another one. These multiset grammars, most efficient area of application is economical combinatorics. However, our object of interest will be unitary multiset grammars, which are modification of the multiset grammars, designed specially for hierarchical systems description, representation, analysis, and synthesis. Here we see the description of department containing from some units the generation of terminal multisets by unitary rules is similar as in multiset grammars. The basics of the further considerations are structural and technological interpretation of unitary rules. It is quite simple. We see that car consists from one frame, one engine, 4 wheels, and 4 chairs. Technological interpretation of unitary rules is some extension of the structural one. Here we see that structural components of the object are extended by multi-objects which define resources necessary for assembling an object from these components. Example illustrates that along with spare parts of the car, we must use some amounts of electrical energy, money, and time of assembling line to assemble this car. So, after that, industrial system may be represented as unitary multi-grammar, where scheme is set of unitary rules in technological interpretation. In the similar way, order completed by industrial system is multiset, which defines amounts of objects which must be assembled. Resources amount necessary for order completion is set of multisets generated by the constructed unitary multi-grammar. Here we see by example that order for 5-car assembling may be completed if there is resource base of lower case. However, real resource base of industrial system may differ from resources amount which system may possess while order completion. Here is the simple condition whether order may be completed by the system, whether it is sufficient or it is not. Impact on industrial system may be represented similarly. It is a multiset which is simply subtracted from the resource base, modeling elimination of these amounts of resources. As may be seen from the example, this impact is critical for the system because resource base after impact is not sufficient for completion by IS. By this, we have simple condition of IS robustness or vulnerability to impact. These are shown at the slide, and the example illustrates how does it works. Until now, we spoke about impacts abstraction of its nature. For example, at the same case, we may consider cyber attacks, which are in fact extraterritorial. However, natural disaster impacts have one special feature: they are localized to some places, areas, territories. So we extend technological interpretation of unitary rules in such a way that we attach the geospatial knowledge to parts of the unitary rules, objects and multi-objects. In a similar way, we extend resource base and order representation. And natural disaster impact we represent simply by set of points areas which are destroyed completely by NDI. After that, NDI in multi-set representation is the subset of resource base affected by NDI. Here we see the criteria which is consequence of the previous one by new form of the subtracted multi-set. As seen, destruction of one of facilities causes that system may execute by one of the ways its order. The next case is partial destruction, where we use the impact representation in usual form. Reverse problem is what part of order may be completed by the affected system. We use for this so-called dual multi-set grammar, which provides us with the result. 1 minute, yes. And here this is the illustration of the set. That's very simplified introduction to the multi-set approach, and there are further directions of its development. I would pay small attention to the last of it, development of big knowledge, which for our opinion would be the next step from the big data. If we estimate volumes of knowledge bases representing real large-scale industrial systems, then we see that there would be millions and millions of such unitary rules. And there would be new culture and new technology able to handle such volumes. We would be glad to collaborate with all the interested in our approach scholars. Thank you for the attention.